Hi, I'm William Rexroat. I've been teaching Python for a little bit over a decade and mainly making games with it because um, that's what students wanted to do with it when I first started. So that's what we went with, making little games because it's that hook that brings kids to the classroom. Um, and what I want to do is go over some of the successes that I've had, so that you can and a little bit of the pitfalls and problems that I've ran into. Um, and one of the things I will warn people about is I'm going to be going over what I'd probably teach over the first 2 months in this presentation that's about 20 minutes long. So it's going to be might be a little bit of a bumpy ride. But I'm recording this with the idea that it can be used as reference more than something that you watch once and be an expert. All right, so first thing I want to talk about is why Python over all the other languages or even some of the products that you can buy, which Python is free. Um, so it is currently really popular. When I started, it was down like 5 or 6, and it's been slowly gaining popularity. So this is from Indeed.com. So this is jobs that they had available. Number of annual job openings range at about 19,000. The pay is really good. Always kind of tempted to jump out, but teaching is so much fun. Um, but overall, the language is popular, good pay, and that's mainly because some large companies are using it, like Instagram and Google or Spotify, to program their stuff. So that really drives up the pay for it. It's also useful in little home projects. Raspberry Pi is a little microcontroller. The Pi is Python, so you can program them in Python. Um, I've done RFID labs with them using this cheap-ish. They're a little bit under $10. Um, Little module that you can plug into the Raspberry Pi that allows you to do FRID stuff with it. So um, for a lab setup between the Raspberry Pi, it'll run you about $50, and you can do like little scanny tags and um, do like students swiping in and doing attendance that way, or making things pop up on the screen, or having it like run a servo, which once you get mechanisms moving, that's always exciting. Robots. My new favorite little robot's called a microbit. That's the little microchip that goes with it, and there's different versions of this robot. I like the cheapest one, which is like $40 plus $10 for the microbit thing, and then you can program robots with Python. And our main topic of conversation today, which is Pygame. And then it's also easy to learn. There's not a lot to this. And with Hello World, that's usually the starting point in which you're going to learn this. And you can look at this and right off the bat kind of read and know what it's going to do. It's going to show Hello World up on the screen. If I go open my Python, show you what that looks like. So print, parentheses, hello world, boop, and then it outputs on the screen. Easy. Takes as long as to write it to learn how to do that. Then this thing that I just opened up is the IED. So to install it, and my PowerPoint, I have a little link here. That'll take you to the Python website so you can install it. Now, Pygame, which we're going to get to in a bit, takes a little bit more to get done, unfortunately. What you got to do is you got to open up your command line. So if you're using a school computer, that may be blocked by your IT folks. So this may be an IT kind of issue. But you put in this in the command line, you hit enter, it'll download Pygame for you. And then if you currently have the integrated language environment open, you're going to have to restart it before running it. Mac is pretty similar, and if you're running this in Linux, Python's usually already installed, and I imagine you're already familiar with terminals, and you'll be able to install this. Then the integrated development environment is where we do a little bit of our testing. But we're going to take a look at Hello World in Python because there's actually quite a bit going on in this simple little chunk. First off, that front part is a function. It's a command that runs the actions. So, and there'll be another one that we're going to talk about, like input. And then when we get to Pygame library, there'll be a ton that we're going to leverage. Parameters, so that's the stuff that goes in the function so that we can tell it what to do. Because if we leave out that, all print does is makes a new line. And then lastly, the stuff that we're sticking in there has a name too. It's a string. A string is a data type that holds characters, sentence words, and so forth, or even some special characters. There's two other major data types. There's integers, which are just whole numbers, and then there's float if we're dealing with decimal places. All right, so new function, input. This is so we can start maybe doing something with the actual Python. So if we go over to Python, to program this, we got two lines. Right now, if I type something in, it goes one line, and as soon as I hit enter, it ends, which doesn't really work for programming. This was one of the first things when I looked at this, I was completely confused about. I was like, how do I program in this? What you have to do is make a space, and where you do that is file new. And then I'll open up. And now we have a window where we can start writing things down. So if I was going to have this program, x equals input, type here, a colon, a little space to make it a little neater, close parentheses, and instantly can see some of the things that we get out of the IDE. We have different colors for things. So this is purple because it's a function. This is green because it's a string. And then print, it's also purple. It's another function. And then when I open up the parentheses, it tells us a little bit about this. Unfortunately, it's written in programmer. So what this is doing is we got a value. If we have commas, they'll be separated by a space. The end thing is a return. But I want to print out that X, put that X in there. How do I run it? Got to go to run. Run module. It's going to ask to save. So I'm going to save this as input. Then it's going to type here. I'm going to type something like hi, and then I'll output hi. So it doesn't do a whole lot right now. Now we can make this a little bit more interesting. We can do like math with it. Now, this is not going to work quite right. It'll let me teach you some things. If I put in 7, it's going to come out with 7 sevens because I multiplied it by 7, and that's really not what I want. So what I need to do is change something. So the problem is input gives us, again, that string type information. So what we got to do is get it over to a number type. So I'm going to put int in here. Boop. And now this is going to change this into a number, and then I can do something with it. But only a whole number, so if we give it a decimal place, it's not going to work great. So I can put it at 7 now, and it multiplies it for me. Great, now I got a calculator. Didn't have one of those yet. All right, so now to get it to start doing something a little bit more interesting, what we really love about computers is sometimes they can do some thinking for us. So in this example, we set x equal to 5. Then we're changing things. If x is greater than 0, then, that's what the colon kind of stands for, we're going to print, and then it's going to do this action. A big thing to note right here is that space that's before print. The white space is what they refer to it as. White space is very important to Python. It's the only language I know of that it's important. Other languages use symbols to kind of mark like this, but I kind of like this for teaching kids because if they can handle a bulleted list, it works the same way. So like it works the same way as a bulleted list. This if here, main topic. This is the subtopic of this. I can put multiple subtopics and have it do things. These are all linked, the if, the elif, and the else, but bulleted list style. So it's going to run this one first. With the elif, it's giving us a sequence. I can put multiple elifs in there, and it'll run through them in sequence. If I had two ifs there, it'd run the first if and then the second if, and if I had a third, it'd run that if. And check each one independently. But how this is set up here is it's a sequential check. So it's the if here, the elif, less than 0, print less than 0. And then we have the else. The else is the bucket at the end that catches all the everything else. And if nothing else fits any of these ifs or elif statements, it's going to be 0. So that's how that's formatted. So now we can have the computer kind of think a little bit. So conditionals. So if you notice, I did some checking of stuff. That's that top part next to the if or the elif, where we're checking to see if a variable is something. We can check if it's equal to, greater than, less than, greater than, equal to, not equal to, and it makes for so that we can start having certain reactions. The other big part that we need to know if we want to start making some decent looking games is loops. We got while loops, which runs off that conditional thing again. And as long as the condition is true, it runs. And then we have for loops so that we can repeat things for a set number of times. So with that amount of information that you have now, you could build a guessing game. So if I go to my folder, oh, wrong folder. Not the folder I want. So if I go here, I got my guessing game. Oh yeah, if you double click on them, they'll open up in the command line. What we want to do is right click edit with IL so we can actually look at the code. So if we put these pieces together, I added another piece. This is import random, which allows us to get libraries because random's not built in. Random range, so I'm getting a random number between 0 and 100 because range is not inclusive, unfortunately. But then I'm setting up another variable for our player guess here and setting it -1 so that there's no chance that when this program starts that it's going to have an right answer. Then I'm printing output, so when the program runs, you can see what it's asking for. And then we got my while loop with a conditional. If x is not equal to y, so if the random number is 5, 5 is not equal to -1, that is true, so this is going to continue running. Y equals int, input, so I'm changing the input into a number here so that we can kind of get, just use numbers. And then if and then I'm checking each case that we may have. So if I run this, guess a number, and so 82. And see, there it works, and fun little game. You can set up the kids to see who can guess it the quickest and whatnot. But when I present this to students, this is what I give them. I print out this screen here and tell them to make something that does this. And then we kind of break it down as a group, being like, well, it's repeating, right? So what's the case that what's causing it to end? Is it a set number of times? Is it repeating until something's true? And then what that is, so that at least they got the starting part there. And we're going to have to check, give some feedback to the user, so you're going to need a couple of inputs. I'd have done this after I taught them about random. And when I go to grade it, whether or not they use random or not, or have a set number that be a difference in credit, whether or not it runs. But guessing games. So I'm guessing it looks like that. Then text-based adventure games are a lot of fun. The students get some like story writing. And then I teach this after we teach functions, because you can make your own functions like print or input. And after we know how to do that, and we have while loops and if else and inputs and prints, we can make this. This is enough knowledge to make that. And I have an example in the folder for you, so you can take a look at that. But these are a lot of fun because the people that are a little more literally minded, they have a lot of fun writing their little stories. Any of the kids that ever play Dungeons and Dragons have a ball with this. You can make some combat stuff in here. It's a little bit more of a task to have like hit points and stuff like that. But is still one of my favorite things to have kids make and then read and go through after the fact. Then we get to Pie Game. After usually I get up to text-based adventure games, and then we make the jump into graphics. So starting off with some like simple things like Pawn, or I made Flappy Jacks when Flappy Bird was all the rage. Then I had my kids make their own remix of it, because I think it was at the point in which they took Flappy Bird off the Apple Store, and then suddenly everyone was like, oh, I miss my Flappy Bird. Like, we can make our own. And I put the examples of these up in there, starting off with Pawn, because Pawn can just use native things that are built into Pie Game, some of the drawing stuff and so forth. And then Flappy Jacks requires importing images and sounds and so forth, so just a little bit later. One of the mistakes I made early on, we made tic-tac-toe, thinking that would be kind of an easy thing. Really, took a good grind. This was probably my second year teaching Python, and this was the downfall of a month of class of nothing really great, and it was complicated and hard. But I have a working example, so you can have tic-tac-toe and kind of on how much needs to go into it. I want to show you a little bit of Pie Game code, so when you hit it, it's a little bit less scary. And then I'm going to go through some of these resources. So where's Pawn? So Pawn. So when you hit Pie Game, there's going to be some imports. These are importing libraries. This kind of starts up the what they call it class. There's class this another thing that's a little bit more crazy than functions, which you can make these classes. But I'll show you where you can read about those. But this starts it up. This makes the screen. This is the little display, so the words at the top of the screen. We need a clock because we're running off frame rate speed so that things don't move too quick. Some true falses to make the game turn on and end a little bit cleaner. Some variables for speeds and stuff. Starting direction and things like that. If I'm doing stuff with font and getting text on the screen, I gotta tell it what type of font I want. And then I got my 2 players being drawn on the screen. So there's the little rectangles. So starting location and ending location for the rectangles. And so they're, then we got the ball. And scores, and those are all my things being stored. And then this is the actual game loop. So, ball game, so that's why I had the true game at the top. Then we got event listeners. That's what these are all about. So, first type is whether or not the game is quitting. This makes this false, so that causes this loop to end here. And this also ends this loop. Then I got my listeners for pressing keys to get the keys to happen. Because it's 2-player, I got the keys for up and down and W and S on the keyboard, so 2 people can use the same keyboard, move around. We got speeds. Then the ball's moving, so this just moves the ball. And then ball direction, whenever it collides with things, what angle it moves at. And then background needs a color, so it's currently white. Then drawing the field on the background, where the score shows up on the screen, the players, and then the ball, and then display flip. Display flip's kind of weird. Because if we go to math class, positive quadrants up here, right in the top right corner. Now with computer monitors, the 0 is here in this corner. That's 0, 0. Which means positive is up here where we can't see it. So they use a command flip to drop it down onto the screen. So if you don't see anything after you're programming, it's mostly missing this display flip line. Clock tick is our frame rate. We've got 20 frames per second with this. And then at the end of everything, we've got to shut it back down because we started it with the init at the beginning. And that's the code for this. So now if we look at it, what games actually look at. And we got pawn. Oh, I'm gonna miss that one. There we go. And we can see how it kind of moves, kind of like pawn. So this is something I'd have the kids try to do like mid-semester, mid to third, fourth quarter, depending on the group of kids and how quick they are getting stuff. But before this, where it'd be is drawing graphics. This is where I go back to my resources because there's a lot. And where do I start? How do I plot out a curriculum? My life changed after I found this website. It's Program Arcade Games. This guy, Paul Craven, I emailed him a decade ago and was like, I found your website. Can I use it for my class in high school? And he's like, fine. And I still email back and forth with him. His email, click on it, be there. And here we go. We got a textbook. He's actually recently printed a textbook. And so you can have a paper copy if that makes you happy. And it goes through the order I typically teach classes. In high school, I usually get to about chapter 13 before the semester is over, which gets us to some of the complicated bits that are really important for upper level programming. Um, then lastly, if you can, Code Academy is a great resources for learning. Code Wars is they give you programming challenges, so it's a great place to copy like bell ringers and um, assignments for homework and so forth. For thanks, Bell. Um, Another great resource is documentation. Documentation for programming languages or websites that you can go through and look up specific chunks of code and so forth. So print, like that print command, I can look at print and find out some of the background about print and where it falls into the realm of everything else that as far as the language goes. Then, or I can look up something larger like making a function. And oops, I gotta spell it right. Function. And I can start reading about making functions. Fortunately, a lot of this stuff is written in programmer, so it's a hard place to start. But what I typically do is I Google up chunks and I give it to the students and I break it down to what it reads, so that maybe if they continue on, they can use some of this to help themselves out. Like random we use a lot. The random module because there's a bunch of different ways that we can be random. So random range, random int, random choice. You can give it a list of things. I'll pick one of the choices. So if you make like a rock, paper, scissors games, that's a good one for that. So something like this. Shuffling, it can shuffle a deck for you. So you can set up a bunch of, so you can make card games. Then Pygame documentation, because Pygame, the library itself, has a lot of the functions it gives you, being able to draw on the screen, allowing for mouse input, putting in music and sounds, and so forth. So I'm gonna wish you good luck. If you need any help, my email address is up and around, and I hope that was useful and not too scary. And enjoy the rest of your Oswego 2020 conference.